Good morning. We're going to look at similarity in right triangles first, and then we're going to look at a little bit of geometric mean, and then we'll look at the rest of that tomorrow. Alright, so let's look at similarity in right triangles first. Alright, so the right triangle similarity theorem states that if the altitude is this line, the height, is drawn to the hypotenuse of a right triangle. Remember, hypotenuse is the side length opposite the right angle. Then the two triangles formed are similar to the original triangle and to each other. Okay, so what that means is this little bitty triangle, BDC, is similar to this other triangle, ADB, and is also similar to the big triangle, ABC. Okay, now, looking at number 1. Identify the similar triangles in the diagram, then sketch them so the corresponding sides and angles have the same orientation. So I'm going to start with my big one. Okay, I'm going to put my right angle down in my left corner every time I draw this. That's going to help me figure out what's corresponding. So I'm drawing my big one. I know that my Q is here. My short side is QR, and then QP. Okay? So that's my big triangle. Now I'm going to do my middle-sized triangle. I'm going to do the same thing. Now here's where my right angle is here. So my middle-sized triangle, my right angle is at S. My short side is SQ. And then my longer side is SP. So P goes here. Okay? And then I'm going to do the same thing for my baby triangle. My right angle is here. My right angle is right here, so it's a S. Okay, then my short side is SR, and my long side is SQ. So that's where my Q goes. Okay, so what this tells us is QPR, triangle QPR, is similar, and you got to go in the same order, to triangle SPQ, which is also similar to triangle SQR. And here's what we did. Q to P, P to R. Q to P to R. S to P, and P to Q. And then S to Q, and Q to R. Okay? Now remember, here's what similarity means. It means that they are proportional. Okay? So this triangle might be 2 times the size of this, and then that one might be 2 times the size of the baby one. Okay, so the big triangle might be 2 times. It just means that all the side lengths are proportional. Okay, so let's look at number 2. It's asking us to find the value of x. Okay, we know, and here's what I'm going to do. I'm going to redraw all my triangles like I just did. Okay, so I'm going to draw it again with my left corner being my right angle. Okay, so that's the big triangle. Those side lengths are 9, 15, and 12. Okay, now I don't have to do the baby one. I can just use this triangle here and figure out what sides should be proportional to each other. So my right angle should be in the same spot. Okay, if you notice, we don't know what 15, we know this whole side. We don't know this little spot. So I can't put anything there. Okay, but what we do know is the hypotenuse. We know that this is 12, and we know that this is x. Okay, so that's what we know. So we know corresponding sides 9 and x, 15 and 12. So you can set up a proportion. You can use triangle to triangle or side to side. Okay, so I'm going to say 9 over x equals 9 over x equals 15 over 12. Once you set up a proportion, you can always cross multiply. So x times 15 is 15x, and 9 times 12 is 108. Okay, so now you have a simple one-step equation. You're dividing by 15. 108 divided by 15 is 7.2. So x equals 7.2. Okay, now you could find the rest of the side lengths based on those, but it's only asking you to find the value of x. Okay, so number 3 is going to work very similarly. Yep, hard to say. Okay, so again, I'm going to separate these into 2 different triangles. I don't have to do it into 3 simply because I'm probably not going to need information from all 3. So here's what we're looking at. We're looking at this big triangle. Okay, I know that my right angle I want in my bottom left corner, and so I am kind of flipping it this way. Okay, so my short side is 11.2. My bottom is 21, and my hypotenuse is 23.8. Okay, now I can choose whichever of the other 2 triangles I want. I'm going to choose this one. Okay, because it's going to be easy to rotate. Okay, so I got my right angle at my bottom left corner, so that means the bottom. We don't know because it gave us this whole bottom, so we can't use 23.8, so we don't know it. We know the hypotenuse is 21, and then we know the side is x. So now, you can't use 21 because we don't know anything here. So we need to use the corresponding sides for the other. Okay, so 11.2 and x correspond, so 11.2 over x equals, these 2 correspond, both hypotenuses, 23.8 over 21. So once you get your proportion set up, and we set up a proportion because they're similar, okay, and that's going to give us an opportunity to solve for x. So when you multiply, you get, I'm going to go down here, 23.8x equals whatever 11.2 times 21 is, which is 235.2. Okay, so to get x by itself, we're going to divide by 23.8. And so x equals 9.8, let's just say 9.9. We'll round it up there. So x equals 9.9. Alright, let's look at one more. We're setting it up the same way. It's giving us all the information for that big triangle. Okay, so I'm going to set it up so that my right angle is in this corner, same corner. Alright, so here's my right angle. My little side is 7. My hypotenuse is 25, which means this side is 24. Okay, I'm going to pick a different side. A different triangle. Alright, let me erase this so we can see. Okay, so I'm picking the middle size triangle, which is here. So I'm just going to pick this up and flip it and turn it around so that it's this way. Okay, so I know that my x is here, and I know that my 24 is still my hypotenuse, and I don't know anything here, so we can't use it. Okay, so now we can't use this because that doesn't have anything to correspond with it. So our corresponding side is 7 over x, and then 25 over 24. That sets up our proportion. Once you have a proportion, you cross multiply. That's 25x equals 7 times 24, which is 168. So to get x by itself, you divide by 25, and you're going to get 6.72. So that side length is 6.72. Okay, let's look at geometric mean. The geometric mean of 2 positive numbers, a and b, is the positive number x such that a over x equals x over b. Okay, and so all that means is if you cross multiplied, you would get x squared equals a times b, which is ab. Okay, and then if you were to solve that, you would take the square root and you would get x equals the square root of ab multiplied together. Okay, so to find the geometric mean of a pair of numbers, all you do is say x equals the square root of 6 times 30. Okay, so 6 times 30 is 180. And you cannot leave root 180, that way you have to simplify. So 180 I know is 2 times 90, which I know is 3 times 30, which I know is 3 times 10, which is 2 times 5. So pick out your pairs. I got a pair of 3s that comes out. I got a pair of 2s that come out. And then 5 is alone, so it stays at home. Then you need to go back and multiply. 3 times 2 is 6. Keep your root 5. Okay, so we're going to do the same thing with 16 and 28. X equals the square root of 16 times 28. Now, I'm not going to multiply this out. I'm going to go ahead and start my factor tree so that I can work with smaller numbers. So I know that 16 is a pair of 4, so I can do that. 28 is 4 times 7, which is a pair of 2s. Now, the reason I didn't go on out with the 4s is because I already made a pair. Okay, so we got a pair of 4s that comes out, a pair of 2s that comes out. And we're going to multiply those. 7 is alone, so it stays at home. So 4 times 2 is 8, root 7. Alright, now, do the same thing with 20. X equals the square root of 12 times 50. Okay, so I'm going to go ahead and simplify 12 and 50 the way they are. So that's 3 times 4, and 4 is 2 times 2. 50 is 2 times 25, which is 5 times 5. So I'm checking for pairs. I got a pair of 2s that comes out, a pair of 5s that comes out. Then I got a 3 and a 2 that are both home, so they stay both alone, so they stay at home. So I got 2 times 5, which is 10, and 3 times 2, which is 6. Okay, and I went through the simplifying radicals quickly because you should know how to do that by now. Okay, so that is how you find the geometric mean. X equals the square root of the two numbers multiplied, and then simplify. Okay, we will go over the rest of geometric mean tomorrow. Hope you have a great day.